Welcome to Concepts in Chemistry. In this talk, we will discuss why atomic masses are unitless. If you look on a periodic table, you notice that the atomic masses of the elements have no units attached to them. So why is that? Atomic masses are unitless because they are relative atomic masses. Relative, as used here, means compared to something. This something is usually another element. At present, the element is carbon-12. Why are atomic masses compared to something? They are compared to something because we can't see and weigh individual atoms on a scale. However, we can weigh the mass of a bunch. To do this, let's say we weighed a bunch of hydrogen atoms and recorded their mass as 0.23 grams, and we weighed another bunch of an equal amount of oxygen atoms and recorded their mass as 3.68 grams. Now, an interesting question comes up. How do we know we have an equal amount of oxygen atoms and hydrogen atoms? We do know we have an equal amount of hydrogen and oxygen atoms if we believe in what Avogadro told us. So what did Avogadro tell us? Avogadro's hypothesis says that equal volumes of gases at the same temperature and pressure contain equal numbers of molecules. Since we took equal volumes of hydrogen and oxygen gases at the same temperature and pressure, then we can assume they contain equal numbers of molecules. Once we trust in this, we can then proceed to calculate the relative atomic mass of hydrogen and oxygen in the following table. So here we do have the mass of hydrogen, which is 0.23 grams, and the mass of oxygen, which is 3.68 grams. So we need to express these masses as a ratio. And to express these masses as a ratio, we need to divide through by the lightest mass. So the lightest mass is 0.23 grams. So we divide 0.23 by 0.23, which will give us 1. And then 3.68 by 0.23, which will give us 16. So if we compare the mass of hydrogen to the mass of oxygen, we will get a relative mass of 1.0 for hydrogen and 16 for oxygen, as shown in the above table. So as you can see, hydrogen, which is the lightest element, has an atomic mass of 1, and then oxygen has an atomic mass of 16. Dalton was the guy that proposed this relative atomic mass idea, and he actually used it to determine the relative atomic mass of elements. And he chose hydrogen as the standard because hydrogen was the lightest element known. And from hydrogen, it moved to oxygen. And now it is carbon-12. Okay, so at present, carbon-12 is the standard, and carbon-12 is an isotope of carbon. So carbon-12 is chosen as a standard and assigned a value of 12 atomic mass units. As a result, the atomic masses of the elements on the periodic table are calculated by determining how heavy or light they are when compared to carbon-12. So let's say if an element is twice as heavy as carbon-12, then that means that the atomic mass of the element is going to be 12 times 2 is going to be 24. Okay. In another video, I'm going to talk about how to determine the atomic mass of an element using isotopic masses and percentage abundance.